This video is about histograms, and basically a histogram is a bar graph of a frequency distribution. So we're going to use the same data set that we used to create our frequency distributions in the last video to create a histogram. So on the histogram, along the vertical edge, we're going to have our frequencies. And along the horizontal edge, we're going to have, you can do this in one of two ways. You can either mark these with the class midpoints or the class boundaries. Well, let's move this down. Sorry if I'm going off the screen there a little bit. So you can have either one of those as your markings. I think class boundaries is the best way to go with this. And so with ours, the first class boundary was 59.5. And then the next one was 74.5. And then the next one after that was 89.5. And the next one after that was 104.5. And the next one after 104.5 was 119.5. And then the last one is 134.5. And so then along the edge, we mark these with frequencies. So our largest frequency in our table was 5. So we just need to go up to 5 here. 1, 2, 3, 4, and 5. So I'm pretty bad with height, especially the farther I get away from the marking. So I'm just going to put some dashed lines here to sort of guide how high my bars need to be. And these don't need to be perfect, of course, but you want them to be, relatively good. So our first class has only one data value in it, so we make a bar, that is 1 unit high. And these are usually colored in. And then our second class from 75 to 89 had 2, so we want a bar that has a height of 2. And then our second one also had a height of 2. Third one had a height of 5. And the last one also had a height that was 5. And so sometimes, especially when I'm drawing them myself, and if I don't have my guide marks on there, I'll just put the frequency above the bar, and that way I know for sure. And so if you're drawing one and, your heights maybe are a little bit off, if you just put the frequency above the bar, then I'll know for sure what your frequency really is. So that would be helpful. So that would be a histogram. You could also do a histogram using the relative frequencies, and that's exactly the same as the histogram that we just made, except for instead of having counts along the edge, we have the percentages along the edge. So we can fairly quickly create that one as well. So we would want percent over here, and our largest percentage was 33.5 or 33.33. So I'm just going to go up by tens here. So 10%, 20%, 30%. And then along the bottom we would label it the same as we have our a regular histogram. Oh, and we should also label this. This is midterm scores. And so our first boundary point was 59.5. Our next one was 74.5. The next one was 89.5, and then 104.5, and 119.5, and the last one, 134.5. And so we were at 6.7% for the first one. And so again, you don't need to be exactly right on with this. So 6% is just a little bit more than half of that 10%. And then the next one had two data values in it, and so that was 13.3%. So that's a little less than halfway up to 20. So about there. Again, they're not going to be perfect, and mine aren't going to be perfect. I don't expect yours to be perfect either. Again, we can write the percentages up on top of the bars, and that will be helpful in indicating exactly where we were. And then 33%, it's about right there. And again, if you write those percentages above, then that's helpful. So there we have the percent histogram. So it's the same histogram as the one that we had here. So my bars have a slightly different height, but not too much. It's only because I labeled them a little bit differently, but overall the same. If you were to do this using technology, they would be exactly the same graphs. You would just have different labelings along the edges. So that is it for a histogram. Here are a couple of examples of some histograms. So these are some common shapes that distributions might have. And so this first one is a bell shape. And so it starts off with not very many, the frequencies are pretty low, and then they increase up to some largest frequency, and then they drop back down. So this would be a bell shape, and this would be an example of something that looks like it might be a normal distribution, we would call it. My D looks like a P. Let me fix that. So this next one, if all of your bars are about the same height, then this is what we would call a uniform distribution. So these next two have sort of this bell-shaped curve, except for, you see this trails off to the right for a long time. And this goes up pretty abruptly, but this trails off to the right, and so this is called being skewed right. This tail goes off to the left for a long time, and so this is skewed left. Next, these are called normal quartile plots. We probably won't be doing these in class. We can do them using Minitab fairly easily, and I think even the graphing calculators can do them as well. So this is a way for us to look at data and determine pretty quickly whether the data might have a normal distribution or not. So what we want is we want the data to be approximately on a line. So this very first one looks like it could be from a data set that's normal. And so the scale on these axes is adjusted so that we get this um, line if the data is normal. So we don't want it to exactly be on the green line, we want it to be close to the line. So if your data looks like it's falling on a line, then we would say that this is approximately normal. So if we look at this next one, we can see that the data does not lie closely on a line like this. These data values up top look like they might, but then there's all of these down here that are not. And so this would not be normal. Now our next example here, so the data lies fairly close to this line, in fact really close, but notice that there's a distinct pattern. So the data goes above the line, and then it comes back across the line and then dips down. So there's this nice sort of symmetric pattern around this line, and because of that, because it's this nice symmetric versus this first example where the data was kind of randomly around the line, so you want that randomness to be there. When it's so nice and perfect and symmetric like that, then um, this is not normal. So this data is taking on some other pattern more than likely, but not a normal distribution. So that is it for the part on histograms. So if you have any questions, let me know. And again, I hope you're having a great day. Thanks.